think we're good. Okay, so hi everybody. My name is Jaron Frost. I am giving a presentation on rigging and animating in Maya. I was going to learn Blender over the last month or so and do a compare and contrast, but I actually don't know Blender and I didn't have time to really get into it. So Maya is something that I use every day for work, and I thought I'd just kind of show you what that program is like. Who in the audience, we have a few 3D modelers. Anyone do rigging or animation at all? A little bit? Okay. If you see me do anything tonight that's totally why would he do it that way? Feel free to raise your hand and be like, actually, I do it this way. Or there's a lot of different ways to rig and animate. So, and I like sharing tips and tricks and everything. And I think that would benefit everyone else here too. So feel free. So who's this guy? My name is Jaron Frost. I go by Fridge Crisis pretty much everywhere online. I've been a technical animator at a local studio called Wildworks for about 5 years. And we make a game called Animal Jam. That's our #1 game. We use Maya and Unity to build that. And I also do a bunch of indie stuff all the time. Go-Go Hamster Chef is a game that I worked on recently that did pretty well on itch.io and YouTube and stuff, which was really fun to see. We're hoping to make some follow-ups and everything. And then I am not affiliated with Maya, despite this presentation seeming somewhat like an advertisement. So what is Maya, though? So Maya is described by Autodesk, which is the company that produces it, as 3D animation and visual effects software, which is a pretty broad description. And it kind of does everything. You can make 3D models, unwrap the UVs, do textures, rigging and animation, which is mostly what I do. You can do physics simulations and effects and rendering. That's particularly for the animation industry. They use Maya a lot too. And in the gaming industry and animation industries, Maya is a pretty common industry standard software. And that to me is probably the #1 reason to learn it, especially if you want to go into any kind of AAA work or a big studio environment. Something like Blender or other cheaper options, totally great for indie development, and I wish more studios would branch out and stuff like that. I think it's a good idea. I've heard a lot about Blender being really good these days. So one of the things that people say when Maya comes up is that Maya is very expensive. And I think that's true. The standard license for 1 seat of Maya is $1,875 a year, which is a lot. But they came out recently with an indie license, which is more like $305 a year, which comes out to $25 a month. And for me, I'm used to kind of paying that amount for the Adobe suite. And so for me, it's yeah, I can justify paying that for my own use. Still not free, but there's that. They do kind of bury that option in their website. So you kind of have to either go directly to this link or Google Maya Indie license in order for it to come up. And Maya is also free for students and educators, as long as you have a valid student credentials or can prove that you're an educator. And everybody also gets a 30-day free trial. So if you just want to learn it for a little bit, you totally can. I think the only restriction for the indie license is that you have to make less than $100,000 a year on your work, which probably includes most of us. That's a pretty high amount. And so other than that, I haven't noticed any features being different. I don't miss anything in there. So. Okay, so I thought for kind of the bulk of this presentation, we could kind of get into Maya and make ourselves a wagging foxtail rig and animation real quick. Just something real easy to create. And I hope that's interesting to everybody and that it's not going to put anyone to sleep. Before we even open Maya, we can talk a little bit about the interface. There are so many buttons and menus because, like I said, it can kind of do everything. But you don't need it to do everything all the time. You really only need to find the ones that you want to use and remember where they are, and it gets a lot easier over time. So the learning curve is kind of high, but once you get it, it's not too bad. Some of the important windows you want to look out for. The outliner is on the left of the screen. That shows you all of the objects that are in your scene. The viewport, which is your camera, it lets you see all the stuff that you're working on. The channel box is over on the right. This contains kind of the basic information about its location, rotation, scale in the scene. The attribute editor is in a tab kind of next to the channel box, usually, and you can go in there to look at more detailed, kind of like hidden attributes of an object, like what material it has, whether or not it uses shadows, or all kinds of stuff in there. So you don't need to go in there all the time, but there are a few things that are useful to be able to find in there. There's tool settings, which is another tab over here on the right. Obviously, like, do you want to move something in world space? Do you want to rotate it in local space, or like gimbal rotation, stuff like that? Those tool settings let you set those. And then down here on the bottom right, there is a animation layers window. When I do my work with animations, I basically just make a new animation layer for every clip that we produce, and then it's easy to export those as individual clips. You just like turn one on, export it, turn on the next one, export it. That's an easy way to do animations. And then there is a graph editor, which is probably mostly important for animation. It's kind of mathy. It's a literal graph with an X and Y, I don't even know what those are called, axis. And it basically just represents like value changes over time. And so we'll get into that a little bit later, but those are the big ones. So step one, we're going to create just a really simple little model for our foxtail. And we're going to kind of follow these steps. And I'm going to swap on over to Maya. I guess it'll take another minute. How many of you have used Maya specifically before? Just you. Okay, great. Let me know if I mislead people. I'll try my best. All right, here we are in Maya. Oh, yeah, okay. So, following along with our instructions, we're going to make a cylinder. I'm going to close Steam too. Don't need that. Okay, so among the many menus that are available to us, there is a poly modeling menu right here. If you click on that, it'll show you kind of some basic shapes that you can create. And let's go ahead and create a cylinder. It puts it in our scene right there. By default, it comes in, of a certain size and with certain subdivisions and all of that. And we can edit some of those values by going over to the channel box and expanding this little input right here. I'm going to go ahead and make it taller and give it some more subdivisions so we have more geometry to work with. Oops. And turn on some round caps here. And I'm going to go ahead, actually that might be the next step. Yeah, set its dimensions and subdivisions. We just did that. Rotate and move it to line up on the Z-axis. Especially at WildWorks, what we do a lot of the time is create like a tail item for an animal. And we care a lot about like the origin point of that tail, because that's where it like attaches to another object in the game. And so for tails, what we usually do, and I think it makes a lot of sense, is to kind of line up the tail on the Z-axis, kind of starting at the origin point. So we can kind of rotate it, move it over here, and, oh, actually that's not the Z-axis. There we go. You can see kind of down here in the corner, this shows you the world axis. Let's get it sort of into position, and then we can use the channel box to kind of like make sure that the values are exactly what we want it to be. Let's see, I don't think we actually need both. Oh. What would that be? Rotate X. There we go. Okay. Now it is on the Z-axis, and we can imagine like if we were to place an animal or something, it would like go right here, and this would be its tail coming out. Okay. Set its pivot to the base of the tail at world origin. That's kind of for similar reasons. We want the place where everything is happening from to be at the world origin. You can turn on grid snap with this button up here, and pressing the D key will open up the pivot edit mode with your move tool. So you can move the pivot of the object instead of the object itself. Press D again to kind of lock it in. And now whenever we select this, this is its origin, its center. And when you rotate it, it's going to do so from that position. Adjusting the edge loops to make a tail shape. This is a little bit of the kind of artsy part. Maya has a couple different selection modes that you can use. And I think Blender has this as well. There's like object selection, vertex selection, edge selection, and face selection. The short key or the hotkeys for that are like F8, F9, F10, F11. For this one, I'm going to, oh, I've got the lock thing. How do I set that? Yeah, there we go. I'm going to go ahead and do edge selection mode, so I can just select each of these edge loops and kind of like scale them to make a roughly foxtail looking thing. Maya can also do soft selection if you tap B, and that will kind of let you edit things that are next to whatever you have selected in like a smaller capacity. So that's really good for things like organic modeling, where you want it to kind of like smooth out across the surface of the object. So we can kind of make this part like a little bit bigger. We can maybe shrink down the base of the tail. Do that over here too. Not going to be the best, but it will do for now. Oops. Oh, and I was going to, I guess it doesn't matter. Subdivisions axis, that's like kind of how many of these horizontal lines we have. That's a bit much. I'm actually going to turn it down to, oh no. Okay, it's too late. We can't go back. This is the tail we got. All right. So that is somewhat foxtail shaped. I think it'll be good enough for our purposes. Great. Okay, and then kind of the final step for finishing up this mesh would be to give it a name, freeze its transformations, and delete its history. So to do that, you can kind of double click on the object in the outliner and give it a name like foxtail mesh. And freezing its transformations basically means taking all of the data in the channel box, like its translate, rotate, scale, and sort of returning it back to a blank slate, sort of baking in some of its locations that or rotations that you've done to it. Obviously, we rotated this, we moved it a little bit. When we freeze those transformations, now it says it's at 0, 0, and no rotation, because this is the natural state of the object now. Also, Maya likes to keep a history of things that you've done to an object. It doesn't keep everything, but it keeps like the bigger like menu commands and stuff that you do to it. And that can it can be useful for going back and editing stuff after the fact, but as you can see, I tried to do that just now and it like messed up. So usually what I do when working on a mesh, or like if a modeler hands a mesh to me, I like having just the history deleted. Like once you have it looking the way you want, it's in the right place, all of that, just wipe out its history. We don't need to go back. This is the mesh that we're working with now. It's nice and clean. Okay. And we have our mesh. Here's one I prepared earlier. And not bad, it's okay. Okay, the technical part, rigging. So this is where we give the mesh joints and controls so that we can move it around and give it animations. So the first thing that we are going to do is to create some joints and name them and kind of put them where they go. So Maya has a couple different like workspace modes. We've been in the modeling one so far. That's sort of the default. It has a rigging kind of set of tools that you can access here. And it changes some of the top level commands, but a lot of these ones down here are the same. It has a rigging toolbar right here where you can find the joint tool. That's this like 2 bone icon. And then when you click on the grid, it will place a joint for you. There is a way to like create multiple joints just by like clicking, and it'll like create a chain and aim them down to the bone and everything, which can be useful in some cases, but it also applies a lot of orientation settings to your joints that can be tricky to deal with, especially for something like this where it's just going to be straight along a path. What I like to do is actually just create one joint, leave its rotations and orientations at world space, and then just duplicate the joint and kind of do my own parenting of them. That just gives me a little bit more like control over where they go and how they're pointed. To change cameras in Maya, you can hold down the space bar and it opens up this kind of shortcut menu. If you click in the middle here, this will show you all of your cameras that you can access real quick. And it's useful for placing joints especially to go to like an orthographic like side view or like a top-down view so you can make sure everything's like really lined up. So I'm going to do that and just place like a handful of joints down this tail. How many do we want? Like 5 is probably enough. And you can kind of just like space them out. Sometimes it's hard to grab them when you have the mesh on. These buttons up here are a filter for selections. So you can press this and go to like all objects off and then just turn on joints. That's the second one. And that makes it really easy to make sure you're only grabbing joints. I do that all the time. Something like that. Another thing that, I'm not sure if this is universal for like game dev in general, but RStudio for sure does it, and I do it myself. At World Origin, I like to have an extra joint that I just call the game node that always kind of stays at World Origin. Or it'll have like a control on it that you can move it if you want, and it's basically the parent of everything. Like it'll just move the entire object. Anything else you've done to it will kind of stay in its local space. So I'm going to do that for this one as well. This first level joint, I'm going to duplicate it and just leave it there. And that's the one I'll call game node. Put that at the top. And then we can kind of name these ones like Tail01, Tail02, Tail03, 4, and 05. So as you can see, I haven't put another joint kind of at the very end of the tail. And when you're creating skinning information for a rig, especially for like a limb like this that just like was one chain that goes down, the joints that you have here, pretty much they're going to mostly be affecting the things that come like after it until you get to the next joint. That's kind of where the skinning will swap over to that joint and then to the next one. So if we had an extra joint at the very end of the tail, there's no more mesh really for that joint to affect. So it basically isn't going to do anything for you. So that one we don't really need. Like this, for all intents and purposes, is the end of the tail. And it'll control the remainder of the mesh that comes after it. But we have one at the front, obviously, because there is mesh here for it to move. Okay, so we've created joints, we've named them. Now we can parent the joints to each other. This determines the relationship between the joints. Our game node's going to be our top level one, and then basically we just put the rest of them into a chain. So you can do that by either clicking on the object and then middle mouse click and drag to another object to like make it its child, or you can click on both of them and then press the P, other order. The order in which you click on things in Maya is important because it parents one to the other, and you want to make sure it's doing it in the right direction. You can see it's created these like triangle pointers that go down the chain, and that's just showing like this joint goes to that one and controls that one next. And if we rotate some joints right now, you can see that like that's what it's doing, and it's gonna look and work like a tail, like you'd expect it to. Those are our joints. All right, creating the controls. These are the things that make it easier for you to grab and move and affect the joints. You technically, in some like workflows, could just like grab a joint and rotate it and like save that information to an animation layer or something. That works technically, but it also becomes really messy, especially when you have, for example, like maybe you have a tail that kind of has some like three-dimensional aspects to it, like it's got a curve in it. And the joint by default has this like -59 rotation in it, right? If you wanted to return this tail to like a base pose or something, or like, oh, I added like a little bit of rotation, but I didn't like it and I want to put it back, like, how do you know what value to use now that you've like changed it? And there are ways that you can like return things to bind pose and stuff like that, but it's really nice to have the values all zeroed out and that be like its base kind of like state. So for that reason, we like making controls that can kind of represent that base state, and like that's what can be zeroed out. Also, it can be really hard to grab joints inside of meshes, especially when you have like, if you can grab everything, you're like, oh, I want to get this joint, but like, oh no, I'm grabbing the mesh. And it's just like really hard sometimes to grab what you want. So making controls that are basically like big boxes around stuff, or like circles, communicates, especially to the animator, like this is the thing for you to easily grab and adjust to do your animations. You don't have to worry about the joints. So I'm going to go ahead and return to our other state here. Great. Creating controls is, yeah, I do have it here. Something that you can do in a number of different ways as well. What we always do is create, we use NURBS curves, which I don't even really know what a NURBS is, but it's basically like a line that you can draw in the scene, or like a box or a shape or something. And we can use those as objects to like grab really easily. So I made this tool that basically like makes it easy to create some of these. This is actually something that I've put in the resources slide at the end of the show. So if you want to like use that tool for yourself in Maya, you can totally do that. I've set it up so that you select a joint and then you pick kind of what color you want the control to be and then what shape you want it to be, and it'll create it. And it'll put it at the same location as your joint, and it'll also name the control with whatever the joint was named. And it also creates a group on top of the control itself. And I'll get to why that's important in a minute. But for now, we can go ahead and create some more controls here. In rigging language, colors sometimes mean different things. For characters, like they have a left and a right side, usually you'll see that blue controls are on the left and red controls are on the right. I just remember like R for red is right, and then the blue is the other one. And then I usually use yellow and purple as like central controls. And that can be really helpful when you have a character that's like crossing their arms or something, and you're like, ooh, this is a mess of lines and stuff for me to look at, and I want to move their right arm. Like you can just look for the red one, and that helps the animator know what they're about to do. So for all of these, I'm going to just go ahead and make them purple. So I'm going to select each joint, make a circle, kind of go down. These are being created a little bit small right now, and we can edit that in a minute. Okay. I'm also going to rotate them 90 degrees and scale them. Okay. That one's too small. Make it a little bigger. This one's a little too big. Make that smaller. And now we have controls that you can see from anywhere around the mesh, and you can grab them really easily. And those are really handy to have for animation. Those are the joint controls. Freezing the control transforms. For the same reason that I mentioned with the joints and also with the mesh, we want these values over here to be nice and cleaned out. So we're going to grab each of the controls, not the groups that they're in, and freeze this information. Right click, go down here to freeze, freeze all. And now they're all nice and zeroed. The groups that these are in, this is kind of where you can store offset information for the control itself. As you can see right now, this group that this control is in has a translate Z offset. That's telling you that, hey, this object is like over here. But the control itself, which is underneath it, is a nice, clean, empty value. And anything that you do to the control itself is just going to be pure animation. That's what we like to like separate, especially if the rigger and animator are different people. That can be really important for making things clear to the other person. Like, here's the thing for you to mess with. This one, don't mess with it. Okay, and then we parent the controls to each other. We're basically doing the same thing that we did with the bones, but we're going to do the controls. This alternating structure of group control is what you want to go for. You have to make sure it's going in the right place. And now you have a bunch of controls that kind of work the same way that your joints are working. And you can, rotate them, move them, whatever you want to do. Okay, so we've got the joints, we've got the controls. Now we have to make them talk to each other. We basically want to make it so that anything you do to the controls, that passes that info to the joints. That's where the actual animation happens. So the thing to make that happen is creating parent constraints between them. We don't actually want to put the objects in the same hierarchy and stuff, because that gets crazy. It's nice to have like the separate hierarchies of joints and controls. But parent constraints can represent a parent-child relationship in the same way without true parenting. So to do that, you just click the control, click the joint that you want to control, create a parent constraint. These are some extra options that you can do, like I only want to do the translation, or I only want to do rotation. You can specify things like that. And it creates this little extra node here that represents that constraint that you've created. So you can tell that something's controlling it. Another nice shortcut in Maya is once you've done a menu command, you can select different objects and then just press G, and it'll repeat whatever the last command was, but on the new things you've selected. So that's a really nice thing to like create these controls really fast, because did I do that weird? Not sure. I did miss 2. Thank you. There we go. Got this nice like symmetrical structure here. I like it. Okay. So now you move the controls, it moves the joints. Beautiful. And then we've got joints, controls. Now let's put the mesh in there. It's the trifecta coming together. We want to have the mesh respond to what the joints are doing. We do that by skinning the mesh to the joints. That's basically a layer of information that says like which of these vertices is looking for movement on which of the joints, and how much is it going to move based on that. Maya has some nice tools for doing that. Basically, you just select the mesh, you select whatever joints you want it to respond to. You go to this skin menu up here, and the first option, bind skin, is what you want to look at. There are a bunch of different options here too. What I usually use for the bind method is called geodesic voxel. This is one that kind of looks at the volume of your mesh and says like, is there a joint like inside of this volume? That's what I want to look at and listen to. Some of the other options, especially just like purely location-based skinning, becomes a problem for like characters that have like their arms down, right? If it's like, oh, I got a wrist joint here, I got some leg mesh right here, it's pretty close, I'm gonna like listen to the wrist. And then you go to move the character's wrist up and their leg is like coming up like crazy. That's a really common thing that you see with like default skinning setups. So geodesic voxel, in my experience, has like helped eliminate a lot of that, because it can tell like that joint's not inside of the leg. I don't, want to listen to that one. And then Now you can move the controls, it moves the joints, and the joints move the mesh. And that is what we want to see. That's a rig. I guess I want to pause here for a second and see, like, does anyone have questions or things that they're like, yeah, Thomas.
How do you decide which axis
Do you mean like the object itself or like each of the controls?
center the base cell on the origin?
The Z? Yeah, so for Maya, Y is up, Z is forward, X is like left and right. If I remember correctly, I think Unity is also that way, but like Unreal is the other way, like Z is up or something. So that's a consideration, like knowing kind of what you're going to be working in may affect like what direction you want to aim stuff. I picked Z because like if you're making a character that's looking forward, in Maya, Z would be forward and the tail would be coming out from behind them like straight out. So for me, it makes sense to like, okay, Z is going to go in like the negative, or the tail is going to go in like negative Z direction. And then all you have to do to like attach it would be like moving this to wherever their spine is. And then you've got a tail that's in the right place. So does that answer your question? Okay. Yes.
So I've worked
Yeah.
on a lot of different teams. I've always heard the artists fight about axes, scale, and that's like
Yeah.
hot artists dispute on what you're doing. Essentially, the project has to decide, and you have to stick with it. The
Yes.
nice thing is, regardless of which animation package you're using, there's tools to change the axes on it. So if you choose the wrong one, you can tweak the numbers after.
Yeah. And I think the game engines too usually have like,
Yes, on import.
just like on import in the game engine, you can be like, oh, pretend the Y is the Z, and it's all good. Yeah. That's something I've run into at work with. We have just this library of thousands of like different items that we have that attach to characters and stuff. And like over the years, the modelers have like, oh, this one's just like up here, kind of in the weird ether. And like this one's down here, like below the grid. And there's like, this creates so many problems because they're not unified in the same place. And that makes it really hard to attach to stuff. You have to like have this extra layer of like, okay, well, do this manual adjustment of moving it here and then save that. And then every time we load the object, like apply that in the game. And it's like, we don't need that if you create it right the first time. Please. Yeah. Any other questions so far? Okay. Yeah. Yes, the skinning, and it does often mess up. That is a very common thing. The first thing I ever did for WildWorks was basically just like fixing skinning for like all day long. Maya has a tool that is in the skin menu. It is paint skin weights. And then if you look in the tool settings, it has this whole like interface here that shows you your joints. And then by default, I think Maya just uses a white black gradient to represent weights. I like the color one because it's a little bit easier to see more specifics about how much weight is assigned to which vertices. But yeah, you can basically like say, oh, I want to paint, so I'm gonna do an add operation, value of like 0.1. And grab your brush and just kind of like, yeah, so much influence right there. And now if you like move this, it's gonna be kind of wonky. I think maybe if we see this one, it'll, well, it's supposed to look wonky. That was the example. There we go. Wonky. So yeah, if you get something like this, it's like, uh-oh, we got a problem. We got to go into the paint skin weights and like remove this skinning information, or like give it back to the joint that's supposed to have it, which in this case would be like this, maybe. Anyway, you can do a lot of noodling with it. And there are third-party tools and like plugins and stuff that make this part a lot easier. There's plugins for a lot of stuff, like auto rigging scripts too, that are like pretty good. That could make all of this like pretty automatic, especially for simple things like this. Anyway, I'm just gonna undo because putting it back is hard. Right. Okay. But yeah, that's how you did it. Skinning. Okay. So we've made a rig. Great. This is what it looks like. Whoa, it moves. Now the animation, the fun part. In Maya, like I said before, I use the animation layers. You can do something where you like have all the animations on one big timeline if you want, and then like break it up into pieces for your game engine or something like that. I like having just different animation layers that I can turn on and off, like I said before. To make a new animation layer, you click right here, and it creates these two objects. One of them is called base animation. That's basically your like parent of all of your animation data. It's always going to play whatever you put on here, which is very frustrating, and I just turn it off all the time and don't touch it. Because once you put animation data on that layer, it's kind of hard to remove, and it just makes things really weird. So block that one. This is the one we actually want to use. I'm going to call this like tail wag. Block base animation. We did that. Add the controls to the layer. We have to pick what objects we want to put into the animation layer that we like care about animating. And the objects we want to add are the controls, because that's where the information comes in, and then it passes it to the joints, passes to the mesh, and so on. So we want the controls in the animation layer. You just right click on it, add selected objects. It kind of comes up with this green circle, which means that the object you have selected is in here and ready to animate. Set the frames per second to 30. You can use other frames per second if you want. The default is 24 because like from the animation history stuff, like 24 frames per second is kind of like the standard. But for gaming stuff, we're more familiar with like 30 or 60 frames per second. I know that Unity at least will like interpolate stuff, like whatever you give it, it'll just create as many in-betweens as you need it to. So 30 is usually great for creating animations. Could do 60 if you want like a lot of detail on every keyframe. I usually do 30. And then we can set a keyframe, move to a different frame, and set another keyframe. To do that, you can select whatever objects you want to put animation data on. And then down here in the bottom is a timeline. This shows you where you're at right now in time. It starts at 1. And to set a keyframe, you just press the S key, and it will create this tiny little red line right here. And that shows that you have a keyframe on that frame. And it'll set the keyframe with whatever data you have in your channel box over here. So if I were to like rotate all of these over to the left and then press S, that's going to lock in this 15-degree Y rotation on this keyframe. I can go to another time, say to like 31, and rotate everything over here and press S. Or in my case, I have it like auto key. So anytime I change anything, it's going to set a keyframe, which is usually pretty nice. Oh, I have it in stepped mode. That's fun. By default, you won't see that. It'll have auto tangents. Okay. And then when you go in between them, it creates all the in-betweens for you, and you have a tail that goes from left to right. Because we want to make a loop, we can copy this frame 1 over to, say, frame 61. So we have a nice, like, I guess that'd be 2 seconds, like to 30 to 60. And you've got a tail wag. You can go back to, or down here, these numbers that I'm editing right now, this is like the range of the total time that you're working with. If we know it's going to loop on 61, we can just set these to 61. And when you press play, a tail wag. Ugh. The auto tangents are not my favorite. But there it is. It's a wagging tail, right? I think spline is different from auto. Is that better? Slightly. Anyway. Okay. So that animation that we made, it works, right? You could stop there and export stuff if you want to. How are we on time, by the way? 20 minutes, great. Okay, we're almost done with this part. There are some simple things you can do to the animation that we just made that will make it look a lot better and more like natural. This is another part where kind of like the artisty animation principles part comes in. When you have like a tail or anything that moves, the part that's at the base like is going to move first, right? Like that's the part that moves first, and then that movement gets kind of transferred down the chain to the later parts. And so if we apply that to the whole WAG, it's going to give it this really nice, smooth, like overlapping motion. And all we have to do to add this into this is basically grab the keyframes, move them over for each of these controls to delay them. There are a few ways you can do that as well, but that's an easy way that I do it. And that's where the graph editor comes in. So we're going to open the graph editor. And this, don't be scared of the graph. It's kind of meth, but it's not too bad. One thing that helped me understand the graph editor, and maybe I can just like do this real fast. Let's make like a bouncing ball. We're going to animate this bouncing ball. I'm not making a rig for it because I'm doing it the fast way. I don't suggest animating this way. Okay. So we added it to the animation layer. We've set a keyframe on 1, set a keyframe on 21. Let's set a keyframe on 11. And we're going to move that one up. So we have, oh my gosh, the stepped mode. I need to turn that off. We have a bouncing ball, right? I'm going to also turn these off for a minute. Bouncing ball. If we look at the graph editor for this bouncing ball that we just made, and we kind of isolate the translate Y, you can see that this kind of looks like if you were to throw the ball up into the air, this is kind of the path it would take, right? It goes up and then it comes down. But you can see that like it kind of has this weird curve to it, right? It like kind of smooths up and smooths down. And that's not really how gravity works. Gravity is going to affect you as much as it can until something stops it, right? And so when it comes down, it's not going to kind of ease into the ground. It's going to kind of look like this, where it's like more gravity, until it just like, bam, hits the ground. And if we throw the ball up, the same thing is pretty much going to happen. It's going to go like straight up. Gravity is going to start affecting it right away until it slows to a stop and comes back down. And so now if you look at what that looks like when you press play, yep, 21. It looks more like a ball that's bouncing more naturally, because the graph is sort of representing what gravity would do, and the path that it would really take. So rotate or translate Y is like the easiest way to kind of like understand that principle, but the same thing applies to anything else. You can do the translates, you can do the rotates, the scales, anything. So that's really useful to be able to edit these things in the graph editor. That's kind of one of the really nice things about it. If you don't come in here and do that, you could be like, oh, I'm gonna make a keyframe here and sort of like make it higher, which in traditional animation would be called like a breakdown, where you're creating extra frames that sort of represent where you want it to be at that time, but it's not one of the extreme poses. But even that doesn't quite have the same effect. Like it helps, but it's not quite as good. I just like going in here, edit these tangents, boom. So there's graph editor, there's that. So we can do the same thing with the tail, except we're going to use the rotations instead of the translate. Let's get rid of that. Turn on our mesh again. Okay, and we were at 61. Controls. So what I'm going to do is select all of the controls except for the first one and highlight just the rotate Y. You can see this, this curve that it's doing. In this case, we do want it to kind of slow in, slow out, because the tail kind of slows down as it gets there and then speeds up again, like that. So the easing is what we want. What we can do here is just kind of like grab all these keys and move them over 2 frames. Maybe we'll do 3 frames. And that's going to make it delayed in comparison to this base one that we haven't moved the frames on. When I do this, I always go back and like add in keyframes at the start and the end, because it's nice to have keyframes that are like everything keyed at frame 1 and at the last frame is kind of like a clean way to maintain your keyframes. You can sort of, let's see, what do we want to do here? Yeah, you can delete that one that's past the end. And then you can kind of like adjust these. I need to change this auto tangent thing. Drive me crazy. Whatever. I'm gonna do that right now, actually. It's gonna drive me nuts. Animation. Default tangent. Auto ease. Maybe auto span. That's fine. Good. Okay. And then I'm gonna kind of repeat the same thing for all of the next ones in the chain. So we've already moved it a little bit. We're gonna move these ones a little bit more. And then adjust these to kind of like maintain the, if you imagine it looping, like it'll kind of maintain the nice like sine wave looking action. Same for just these two. 3 frames. Move this down. Kind of adjust the angle here. And last one. This might be too much. Might be kind of crazy. Another thing that you can do is also amplify the later ones a little bit. That kind of gives it like a whip motion. The base kind of usually doesn't move quite as much as like the end does. It can like really whip around, especially if it's like a fast moving tail. And that's going to be like a big rotation really fast. So you can grab like the whole graph and just like scale it up to make it more extreme. Do that for the last couple to kind of make it more dramatic. Okay, and hopefully when we press play, ooh, nice. Get that nice overlapping tail motion. And that is an easy way to make it look a little bit more natural. Yeah, that makes me happy. I guess this is why I do what I do, because I'm like, ah, good, yes, that little adrenaline rush. So yeah, that's an animation. And here's one I prepared earlier. Yay. Okay, so that's kind of the crash course of creating a quick model rig animation in Maya. You can then like export that, put it into Unreal, put it into Unity, whatever you want to do with it. This is a screen of like some of the hotkeys that I use a lot. Feel free to like take a picture or look it up later. I'll post the slides and stuff. These are things that make your life a little bit easier if you like remember them. Yep, that's that. And then resources. So here's again a link to that Maya Indie license thing. These are 2 YouTube series that I really like. This rigging in Maya one it's like pretty lengthy, and it goes into a lot of detail on like the very basic building blocks of how to do like joints and controls and all this stuff. And I haven't watched the whole thing, but all of the pieces that I've watched have really helped me understand how to do stuff, and it seems to line up with the way that I was taught like at work. And that's like my main context for like how to rig is like, I've only worked at one place, so I could be doing it wrong from everyone else, but hopefully not too much different. And this series was like pretty good. And then the principles of animation. This one is kind of like the classic Disney animators came up with these principles of animation that make things just like look so much better. This series uses 2D examples, but the principles are the same in 3D. They can be applied to 3D just as well. And then this is a link to that control creator script if you want it. And are there any more questions now? Anybody want to, I don't know. Anyone want to see anything else like real quick before we finish? How much more time do we have? Are we close? 10 minutes, okay. Ooh. I trying to think if I put any on my portfolio. I could try to look for one. Don't judge me by my search history. I'm sorry. No, you didn't see anything. Okay. Here's like my portfolio. I don't think I put like rigs in here. I mostly just did animations. It's gonna load for a second, but come on, it's going so slow. There we go. These are some animations that I worked on for Animal Jam. The rigs for these are obviously a lot more complicated, but one of my other coworkers built a auto rigging script that kind of like sets up animal-like rigs really easily, and I've really liked working with those. He has, he calls it, what is it, like a ribbon spine. He uses Maya like hair follicle systems to create a chain of joints that can kind of like, I don't know how it works exactly, but it makes it like really smooth, and you can control kind of any point in there, and it'll like kind of interpolate things, and like makes it really nice. I like those. I did a rig for GoGo Hamster Chef that can kind of give you previews of like different like sprite swapping like eyes and stuff, because they were just like sprite eyes. And so I set up little controls for like, oh, make him look like Squinty or like big eyes. And it was fun to be able to like see that in Maya, not just in the game engine. So, yeah. Anything else? Okay, thanks everybody. That's it. I'll post the slideshow in the Discord.